For problem 2, we want to consider the functions f of x equals negative x squared plus 4x minus 1, and g of x is x squared minus 4x plus 5. And we'll determine the area of the region between the two curves that is shaded. So I only want to calculate the area here. And we've labeled the graphs for you, but we actually sort of didn't have to, because if we see a quadratic with a negative up front, we know it turns down, so that has to be f of x. And a quadratic with a positive a value in front of the squared term means it opens up, so that would have been g of x. So we could have actually reasoned that out even if we hadn't labeled them for you. But now we need to know, well, where do I start and stop the integral? So when we set up the integral, we need to have an x1 and an x2 to evaluate in between. So in order to determine where the two curves intersect, well, they're going to have the same y value at each of these points, so we set our functions equal to each other. So x squared minus 4x plus 5 has to equal negative x squared plus 4x plus 1. Oops, sorry, it's minus 1. And we know that there's going to be two x values that come out because I can visually see there's 2 points of intersection. So now I'm going to move all the terms over to one side, so I'm going to add an x squared to both sides and get 2x squared. I'm going to subtract a 4x from both sides and get negative 8x, and I'm going to add 1 and get positive 6 equals 0. Then I'm going to divide everything by 2 because they're all divisible by 2. So now I have an equation I can factor. So x minus 3 times x minus 1 is 0. So x equals 1 and 3 is where they intersect. So this is going to be 1 to 3. I don't need the y values, but if I plugged 1 and 3 back into either one of these functions, it would give me the y values. So this is 0.32 and this is 0.12. But all I really needed were these x values. So it says verify that f of x is the top function as indicated in the diagram. So the way that I would do that is I can pick any value between 1 and 3, and the y value for f should be bigger than the y value from g. So I'm going to pick x equals 2. So f of 2 is negative 4 plus 8 minus 1. So negative 4 plus 8 gives me 4. 4 minus 1 is 3. If I plug the exact same value into g of x, I'll get positive 4 minus 8 plus 5. So 4 minus 8 is negative 4, and negative 4 plus 5 is positive 1. So f of 2 is bigger than g of 2, so we know that f is the top function. So even though we knew this by looking at the graph, if you can't graph it, this is the way you could verify. So set up the definite integral representing the area of the shaded region. So we're going to say, well, it's 1 to 3 of f of x, which is negative x squared plus 4x minus 1 minus g of x. So you have to subtract the whole thing, so I need parentheses because I need that negative sign to distribute properly. So now I'm going to simplify this by combining like terms. Oops, it's 1. So negative x squared minus x squared is negative 2x squared. 4x plus 4x is 8x. And negative 1 minus 5 is negative 6. So there is the integral that will give us the area of the shaded region. Now they want us to evaluate it. So this is a polynomial. So I'm going to get negative 2x cubed divided by 3 plus 8x squared divided by 2, which is 4x squared, minus 6x. And I'm going to evaluate that from 1 to 3. So now I'm going to plug in 3, and I'm going to get negative 2/3 times 27 plus 4 times 9 minus 18 minus, in parentheses, now I'm going to plug in 1, negative 2/3 plus 4 minus 6. So this 3 cancels with the 27 and gives me a 9, and I get negative 18. 4 times 9 is 36, minus 18, and then a minus 2/3 is plus 2/3, minus 4 plus 6. So now negative 18 and negative 18 add up to negative 36, so these three terms add up to 0. So I have 2/3, negative 4 plus 6 is positive 2, and you can leave it like this. If you want to get a common denominator, 2 times 3 is 6, plus 2 is 8, so it does simplify to 8/3, but you could stop right there.